In the winter of 1939, as Europe plunged into war, the United States watched from across the Atlantic with a blend of dread, uncertainty, and reluctant vigilance. American factories still thrummed with the rhythms of peacetime production, cars rolling out of Detroit, steel casting in Pittsburgh, consumer goods shipping from East Coast ports. Yet beneath the hum of industrial prosperity was a quiet, growing realization that the world had shifted into a far more dangerous era. Reports of German blitzkrieg, with its coordinated armor, infantry, and air power, demonstrated a new kind of mechanized warfare, one that demanded a level of industrial readiness unmatched by anything seen before. Even before Roosevelt spoke the phrase, "arsenal of democracy," the fundamental question loomed. Could the United States pivot its enormous economic engine quickly enough to counter a global threat rising across two oceans? American military planners were painfully aware of the nation's vulnerabilities. The U.S. Army ranked 17th in the world, an astonishingly low position for a nation with unparalleled natural resources and industrial wealth. Much of its equipment was outdated, its supply reserves insufficient, and its armaments drastically inferior to those of Germany, which had been secretly rearming for years. Yet what the United States did possess was an unmatched capability for mass production. No other country on Earth produced as many cars, as much steel, as much oil, or as many machine tools. The issue was not whether America could produce weapons. It was whether it could move fast enough to meet a rapidly escalating conflict that threatened to engulf the world. Roosevelt and his closest advisors quickly recognized that this conflict would be defined not only by soldiers and strategies, but by factories and fuel, by assembly lines and industrial capacity. Germany's early victories were powered by astonishing levels of mechanization. Tanks rolling on meticulously manufactured treads, aircraft fueled by state-directed industry, armies equipped with a consistency only centralized production could provide. For the embattled democracies of Europe, survival required mountains of weapons delivered at speeds that only America could hope to achieve. The U.S. would not simply be asked to build tools of war. It would be asked to manufacture time, buying Britain months, buying resistance movements hope, and buying freedom a fighting chance. But transforming the American economy was far from guaranteed. The nation remained sharply divided between isolationists and interventionists, between those scarred by the disillusionment of World War I and those who saw the storm clouds thickening over Europe. Many industrialists were hesitant to abandon lucrative consumer markets in favor of uncertain military contracts. Factories had not yet been retooled for war, and shifting production meant enormous costs, logistical complications, and nationwide political debate. Roosevelt understood that winning public opinion would be just as crucial as winning industrial cooperation. Mobilization would require not only steel and labor, but persuasion, leadership, and moral resolve. To rally support, Roosevelt began framing America's role in the conflict as a defense of global democracy rather than a march toward another European war. He argued that if Britain fell, the Atlantic would no longer be a barrier. It would be a pathway for authoritarianism to reach American shores. The factories that built cars and appliances, he insisted, must become the engines of freedom for nations resisting tyranny. This rhetorical shift began transforming public perception, allowing citizens to see industrial mobilization not as a step toward unwanted war, but as a moral duty in defense of civilization itself. It was one of the most strategic political recalibrations in American history. Inside the War Department, plans for an unprecedented expansion of military production were quietly taking shape. Engineers and strategists proposed massive new aircraft plants, shipyards, tank factories, munitions facilities, and synthetic rubber plants. It was estimated that the U.S. would need to produce aircraft at levels 10 times greater than anything achieved before, and tanks by the tens of thousands. Vast training grounds, industrial supply chains, and metalworks would need to be built or expanded almost overnight. The scale of the undertaking was staggering, yet the urgency of the global crisis left no alternative. Meanwhile, a handful of industrial innovators had already begun preparing for the coming transformation. William Knudsen of General Motors and Charles Sorensen of Ford quietly studied European production methods, analyzed German efficiency, and explored how American assembly lines could be adapted for military manufacturing. Henry J. Kaiser envisioned shipyards that could build Liberty ships in days rather than months, a concept so bold that many initially dismissed it as impossible. Their forward-thinking efforts would soon produce wartime factories capable of feats the world had never imagined. Aircraft rolling off lines in hours, ships constructed faster than enemy submarines could sink them, and a workforce whose skill would become one of the Allies' greatest strategic assets. By the end of 1939, the foundation of the arsenal of democracy was already forming, even if public awareness lagged behind. America possessed the raw materials, the engineering prowess, and the organizational talent needed to supply entire nations fighting for survival. What it lacked was a unified decision to act. Yet as the Axis powers expanded and the fires of war spread, pressure mounted on America's political leaders and industrialists alike. Quietly but decisively, the machinery of transformation had begun turning. The factories that would one day help win the war were slowly shifting from peacetime comfort to wartime urgency. The greatest industrial mobilization in human history was no longer a possibility. It was an approaching reality that would reshape America, fuel Allied victory, and alter the course of modern civilization. As the 1940s dawned, the American industrial landscape began to shift in ways few citizens fully understood. Factory floors that once echoed with the rhythmic assembly of refrigerators, radios, and automobiles started to receive new blueprints. Designs for engines, fuselages, artillery shells, and armored hulls. The American workforce, still recovering from the economic shock of the Great Depression, suddenly found itself standing at the edge of an unprecedented transformation. Industries that had spent a decade struggling for survival were about to surge with new purpose, driven by the escalating global crisis. The shift was subtle at first, experimental prototypes here, government contracts there, but soon the momentum grew undeniable. America's factories were preparing to become the lifeline of the free world, whether the public realized it or not. President Roosevelt's administration took the first decisive steps by convening meetings with the titans of American industry. Men like William Knudsen, who had orchestrated General Motors' rise to dominance, sat across from government officials discussing output quotas for equipment that did not yet exist. Knudsen understood what few others did, that wartime production would not be achieved through mere expansion, but through complete reinvention. Factories would have to be retooled from the ground up, supply chains reconfigured, and labor forces retrained. This was not a matter of building more, it was a matter of building differently. Roosevelt famously admired Knudsen's mastery of scale, telling colleagues that if anyone could turn America into the world's workshop, it was the man who once built more cars than Germany, Japan, and Britain combined. In Detroit, automakers grappled with a daunting reality. The machinery that had mastered mass production of automobiles was suddenly expected to churn out aircraft engines, armored vehicles, and precision instruments with tolerances far beyond those required for consumer goods. Ford engineers studied British and German aircraft manufacturing techniques, trying to understand how to integrate aviation-level precision into their assembly line philosophy. The challenge was monumental. A single B-24 Liberator bomber contained over 450,000 individual parts, each requiring flawless accuracy. Yet Ford was determined to crack the code, envisioning a future in which warplanes rolled off lines as reliably as Model Ts once had. Meanwhile, in the steel towns of Pennsylvania and Ohio, the blast furnaces roared back to life with renewed intensity. Steel was the lifeblood of modern warfare. Tanks, ships, aircraft, munitions, and infrastructure all depended on its production. American steelmakers anticipated that demand would soon exceed anything witnessed during World War I. Massive orders for armor plating, aircraft alloys, heavy guns, and naval components began pouring in from Washington. Every ton mattered, and every furnace became part of a national effort that would soon define the American identity. By early 1941, U.S. steel mills were operating at levels that pushed the limits of their capacity, laying the groundwork for the vast quantities needed once war production hit its stride. Shipbuilding, too, entered an era of extraordinary innovation. The looming threat posed by German U-boats forced American planners to rethink maritime logistics entirely. Traditional shipyards, designed for slow, meticulous construction, were no longer adequate. This realization sparked the rise of Henry J. Kaiser, a visionary without any prior experience in shipbuilding, yet whose obsession with efficiency would revolutionize the industry. Kaiser pioneered modular ship construction, breaking vessels into prefabricated sections that could be assembled like an industrial puzzle. His dream was audacious: to build cargo ships faster than the Nazis could sink them. Skeptics dismissed the idea as impossible, but within a few years, Kaiser's shipyards would redefine the very notion of industrial speed. Across the nation, smaller manufacturers found themselves drawn into the widening web of defense production. Companies that once produced typewriters, sewing machines, and vacuum cleaners shifted to making gun components, ball bearings, precision optics, and airplane instruments. The War Department distributed designs that allowed even mid-sized firms to contribute vital pieces that would eventually be assembled into tanks, aircraft, or warships. This decentralization of production gave the U.S. an enormous strategic advantage. Germany's rigid, centralized industrial system could never match the adaptability and diversity of American manufacturing, where thousands of companies, each specializing in something unique, could be synchronized into a massive, interlocking supply chain. Yet no transformation was more profound than the awakening of the American workforce. Millions of men and women found themselves drawn into factories, workshops, and shipyards that had suddenly become the epicenters of national purpose. Older skilled workers became mentors to younger recruits. Women entered industrial fields in unprecedented numbers. Immigrants, minorities, and rural laborers found opportunities that had been unimaginable just a few years earlier. The workforce became a tapestry of backgrounds and abilities unified by a common mission. The tools they wielded, welders, lathes, presses, drills, became the instruments through which American democracy would defend itself and its allies. By mid-1940, the transformation was in full motion. Though the United States had not yet entered the war, the factories were no longer operating as civilian enterprises. They were operating as the embryonic arsenal of democracy. Production goals grew more ambitious, coordination deepened, and the industrial pulse of the nation quickened with each passing month. America was not yet at war, but its factories were preparing for the moment when hesitation would no longer be possible. The machines were warming, the workers were learning, and the industrial giant was awakening. The foundations of victory were being laid not on battlefields, but on factory floors, long before a single American soldier fired a shot. The turning point in America's industrial awakening came when President Franklin D. Roosevelt made the bold decision to initiate a national rearmament campaign while the country was still officially at peace. It was a political gamble of extraordinary scale. Isolationist sentiment dominated Congress, and many Americans feared that any investment in armaments meant a quiet march toward war. But Roosevelt believed that preparing early was not a step toward conflict. It was a safeguard against catastrophe. He summoned his closest economic and military advisors to craft what became the most ambitious mobilization blueprint in American history. Every element of this strategy reflected Roosevelt's conviction that the global balance of power was shifting rapidly, and that only a fully awakened American industry could prevent democracy from collapsing overseas. At the heart of this plan was the National Defense Advisory Commission, created in 1940 to bridge the gap between government demands and private industrial capabilities. Roosevelt knew the federal bureaucracy alone could not manage a mobilization of such magnitude. The commission brought together industrial giants, scientists, labor leaders, and military planners, forming an unprecedented coalition that represented every layer of American society. Their task was daunting: analyze existing production, forecast future needs, negotiate contracts, and synchronize efforts across thousands of factories. What emerged from these meetings was a blueprint that treated industry not as a collection of independent companies, but as a unified national engine whose power could be directed with purpose. Behind the scenes, Roosevelt relied heavily on individuals who possessed both industrial brilliance and organizational genius. William Knudsen became the architect of industrial mobilization, translating Washington's strategic goals into factory floor realities. He traveled relentlessly, visiting plants across the country, persuading skeptical executives to commit their companies to defense production. Knudsen's genius lay in his ability to speak the language of manufacturers. He could identify bottlenecks instantly, redesign workflows on the spot, and inspire confidence in industrialists who feared government oversight. Under his influence, factories began the slow but steady conversion from civilian manufacturing to military output, even before Congress approved full-scale funding. To complement this industrial transformation, Roosevelt sought guidance from economists who specialized in large-scale production. One of his most influential advisors, Bernard Baruch, had overseen wartime production during World War I and knew the dangers of chaos and redundancy. Baruch pushed for centralized direction of raw materials, standardized designs for equipment, and careful monitoring of supply chains. He understood that a war economy required unity and discipline, not improvisation. Although Roosevelt did not adopt all of Baruch's recommendations immediately, the principles of streamlined production and resource management became core components of the mobilization strategy that unfolded in the years ahead. As this blueprint took shape, military planners began calculating the arsenal America would need, not merely for its own defense, but for the survival of its allies. The figures were staggering: tens of thousands of aircraft, hundreds of thousands of vehicles, enormous quantities of munitions, and a navy capable of confronting threats in both the Atlantic and Pacific. These projections were not abstract fantasies. They were the mathematical representation of the war that Roosevelt believed was coming. Every bomber, every tank, every cargo ship represented a ratio of survival for Britain, for China, for the remnants of democratic Europe. The scale of production required was unprecedented, but the urgency behind these numbers gave the mobilization blueprint the moral weight it needed to overcome political resistance. Funding this transformation demanded another bold leap. Roosevelt pushed Congress to authorize vast appropriations for defense, even as the nation grappled with lingering economic hardship. Critics accused him of reckless spending, but Roosevelt argued that the cost of inaction would be far greater. Factories required new machinery, training programs, and expanded power grids to meet the demands of wartime production. Steel mills needed additional furnaces, aluminum plants required dramatic expansion, and shipyards needed new dry docks and welding stations. The federal government intervened directly, offering loans, subsidies, and guaranteed contracts that transformed hesitant businesses into active participants in the national effort. Slowly, the tide turned. Congress endorsed the president's investments, recognizing that to ignore Germany and Japan's militarization was to invite disaster. Perhaps the most radical element of Roosevelt's blueprint was the call for a production-first strategy, which placed industry at the center of national defense even before the military itself. In Roosevelt's view, soldiers could not fight without tanks, pilots could not fly without engines, and ships could not sail without steel. Victory would not come from battlefield brilliance alone. It would come from the relentless, disciplined output of America's factories. This philosophy marked a profound departure from traditional thinking, elevating industrial power to the same strategic significance as manpower or military planning. It foreshadowed a new era in which nations would wage war with assembly lines as much as with armies. By the end of 1940, the mobilization blueprint was firmly in motion. Factories were retooling, supply chains expanding, and the American workforce preparing for a transformation that would reshape life in every city and town. Roosevelt had taken the first step in turning the United States into the arsenal of democracy, even as the storm clouds of global war gathered ominously. What remained was the monumental task of converting this plan, this blueprint of numbers, machines, and dreams, into tangible output. America had outlined its path. Now it needed to walk it, one factory shift at a time. The conversion of American factories from civilian to military production was one of the most dramatic industrial transformations in human history. It began gradually, almost imperceptibly, as manufacturers tested new assembly configurations and experimented with unfamiliar materials. But once contracts accelerated and global emergencies deepened, the shift took on the momentum of a tidal wave. Factories that had once built washing machines, refrigerators, bicycles, and radios suddenly found themselves redesigning their assembly lines to accommodate artillery casings, aircraft components, and armored vehicle parts. For many executives, the experience felt like awakening in a new industrial universe, one where the demands of war overshadowed every previous assumption about manufacturing speed, volume, and precision. At Ford's massive River Rouge complex, the transformation was nothing short of astonishing. Known as the largest integrated factory in the world, the Rouge had been designed to turn raw materials into automobiles with unparalleled efficiency. Now, under government contract, its machinery was torn up, reconfigured, and rebuilt to accommodate the production of bombers and military vehicles. Ford engineers worked alongside military planners to create new jigs, welding stations, and heat treatment processes, crafting a manufacturing environment capable of producing equipment with tolerances far more exacting than anything required by civilian automobiles. The once familiar clatter of car frames gave way to the whir of rivet guns and the echo of engines destined for combat over distant continents. General Motors, too, entered a period of sweeping reinvention. Its plants, spread across multiple states, formed an industrial constellation that the government recognized as indispensable. GM branches that had once focused on consumer goods shifted almost overnight into centers for tank production, aircraft engine manufacture, and the creation of diesel power units for naval vessels. Engineers accustomed to designing sleek Buick and Cadillac models were suddenly calculating armor thickness, ballistic resistance, and torque ratios for combat conditions. The corporate culture evolved accordingly. Boardrooms that once discussed marketing trends now dealt with logistics chains, steel quotas, and the complexities of coordinating production with Britain and the Soviet Union. Even companies far removed from heavy industry found themselves recruited into the mobilization effort. The Singer Corporation, famous for sewing machines, transitioned to producing precision firearms and mechanical components for military aircraft. Typewriter companies manufactured parts for rifles and machine guns. Toy manufacturers shifted to producing compasses, signal lamps, and delicate electrical components. The United States Rubber Company redirected its factories to create millions of military boots, life rafts, tires, and gaskets. These shifts demonstrated the remarkable adaptability of American industry, its ability to retool not just machines, but entire corporate identities in response to national need. For workers, the conversion meant navigating a rapidly transforming professional landscape. Skilled labor was in short supply, forcing factories to introduce aggressive training programs that could elevate inexperienced workers to competent machinists in mere weeks. Training centers sprang up adjacent to factories, sometimes operating around the clock as thousands learned welding, riveting, blueprint reading, and precision machining. The emphasis on speed did not diminish the emphasis on quality. Military inspectors roamed factory floors with gauges, calipers, and hardened eyes, ensuring that every component met exacting standards. A single flaw in a bomber's engine or a tank's gearbox could cost lives thousands of miles away, a reality that every worker understood with quiet solemnity. The conversion effort also highlighted the importance of supply chain management on a scale America had never attempted. Raw materials, steel, aluminum, copper, rubber, became strategic assets that had to be carefully rationed and allocated. Government agencies coordinated shipments across railroads, barges, and convoys, ensuring that every factory received the materials necessary to maintain uninterrupted production. Shortages required creative solutions. Chemists developed synthetic rubber to replace imports cut off by Japan's invasion of Southeast Asia, while metallurgists experimented with new alloys that reduced reliance on scarce elements. Every bottleneck solved brought the nation one step closer to sustained mass production. The psychological impact of the conversion on the national consciousness was profound. Citizens who once viewed factories as engines of prosperity now saw them as guardians of global freedom. Executives spoke of duty rather than profit. Workers took pride in knowing that their labor directly influenced the outcome of battles across Africa, Europe, and the Pacific. Newspapers published photo essays of assembly lines building war machines with unprecedented speed, reinforcing the message that every bolt tightened and every piston installed carried strategic importance. America's identity shifted subtly, moving from a nation focused on domestic recovery to one embracing the vast responsibility of supporting the free world. By the end of 1941, the great industrial conversion was well underway. Civilian production had shrunk dramatically, replaced by vast and growing military output. Factories glowed through the night, their floodlights illuminating columns of workers changing shifts as trains and trucks carried materials to and from the gates. The United States had not yet fully entered the war, but its factories were already beating out the rhythm of an industrial revolution unlike anything the world had ever seen. The blueprint Roosevelt had envisioned was now becoming reality, one retooled machine at a time. The transformation of American factories into engines of war was not an overnight miracle, but by early 1941, something extraordinary was underway on the shop floors across the nation. In places like Detroit, Cleveland, Pittsburgh, and Baltimore, industrial plants began humming with a confidence that had been buried since the Great Depression. Men and women streamed into facilities at dawn, stepping onto assembly lines that were evolving from slow, peacetime manufacturing into mechanized, highly synchronized systems built to deliver weapons faster than any adversary imagined possible. The air smelled of hot oil, steel shavings, and fresh paint, and the clang of metal reverberated like a heartbeat. Engineers reworked production layouts, squeezing inefficiencies out of every corner, while foremen barked instructions above the thunder of presses and riveting guns. It was here, on these chaotic, crowded floors, that America's future arsenal began to take shape. The demand from Washington forced companies into unprecedented innovation. The automobile industry, which had once displayed new models each year like clockwork, now found itself told to shut down civilian production entirely. Factories that once crafted sedans were rewired to forge tank hulls, aircraft wings, and artillery components. Engineers who had spent careers perfecting chrome finishes suddenly became experts at balancing crankshafts for fighter planes. General Motors, Ford, and Chrysler competed not in styling contests, but in output volume, each racing to prove that American industry could outperform German and Japanese production. As government contracts flooded in, CEOs realized that what mattered most was not profit margins, but speed, scale, and national survival. They embraced a wartime identity, pivoting their entire corporate machinery towards something larger than commerce, the defense of freedom. One of the most astonishing transformations unfolded at Ford's Willow Run facility, which evolved from empty farmland into the largest factory under one roof in the world. Henry Ford's team attempted something no one believed possible, mass-producing heavy bombers on a moving assembly line. The skepticism was intense. Even military officials questioned whether an aircraft with over 1 million parts could be built like a Model T. Yet Ford's engineers persisted, designing conveyor systems, overhead cranes, and modular assembly stations to break the B-24 Liberator into thousands of simpler processes. Skilled workers trained day and night, adapting automotive know-how to aviation precision. By the time the line was fully operational, it shocked global observers. Willow Run began producing a completed bomber every hour, a statistic that symbolized the almost supernatural strength of American manufacturing. At the same time, the nation's steel mills roared back to life with a fury unmatched in their history. In cities like Gary, Indiana, and Bethlehem, Pennsylvania, blast furnaces burned so hot that the night sky glowed red for miles. Train cars filled with iron, ore, coal, and limestone rolled into the plants nonstop, feeding smelters that worked around the clock. The molten steel that poured out the other end became the bones of Liberty's ships, tanks, rifles, and infrastructure for thousands of new factories. Millworkers, many of them immigrants, African Americans fleeing the Jim Crow South, and young men awaiting deployment, labored in brutal heat, knowing that every ton of steel was another step toward victory. The mills set output records year after year, and by 1944, U.S. steel production exceeded that of Germany and Japan combined. Shipyards, too, became symbols of American industrial might. On both coasts and along rivers inland, maritime construction exploded to support a navy that would soon stretch across every ocean. The Liberty Ship program demonstrated a revolutionary idea: use modular construction to build cargo ships in weeks instead of months. Workers assembled prefabricated sections like giant puzzle pieces, welding them together in open-air yards that never slept. The spectacle of production reached its peak when the SS Robert E. Peary was launched just 4.5 days after her keel was laid, a publicity triumph that stunned the world and sent a chilling message to the Axis powers. Even as U-boats prowled the Atlantic, the United States replaced lost tonnage faster than Germany could sink it. Women surged into the industrial workforce in numbers unimaginable just a few years earlier. With millions of men entering the military, factories recruited women to take over machine shops, riveting teams, welding stations, and quality control units. Posters featuring Rosie the Riveter celebrated these new workers, but the reality went far beyond propaganda. Women achieved precision levels equal to or better than their male predecessors, mastering technical skills and maintaining relentless production schedules. Daycare centers and communal kitchens appeared near factories to support these working mothers, and for the first time, women became indispensable to the beating heart of American industry. Their contribution would permanently reshape gender roles and the future of the labor force. Behind the scenes, the federal government played a critical coordinating role. The Office of Production Management and later the War Production Board acted like the brain of a vast industrial organism, determining which factories made what, allocating raw materials, and preventing companies from competing for the same resources. Bureaucrats, engineers, and military planners collaborated with private executives to map out supply chains that stretched from ore mines to final assembly lines. This unprecedented partnership between government and industry, sometimes tense but always purposeful, proved vital to converting the nation from a consumer economy into a war economy. Through strict quotas and efficiency standards, the government ensured that every factory, no matter how small, contributed to a unified national strategy. By 1942, the entire character of America's industrial landscape had changed. The smokestacks rising above cities no longer symbolized simple commerce. They represented the sheer willpower of a nation preparing for global conflict. Railroad yards filled with tanks instead of tractors. Warehouses stacked crates of ammunition instead of furniture. The scale of production reached levels so staggering that foreign observers struggled to comprehend it. German intelligence, which had underestimated U.S. capabilities, began issuing urgent internal reports warning that if America's industrial mobilization continued, the Axis powers would face an opponent capable of overwhelming them by sheer output. And so, as the machinery of democracy roared to life, the factories of the United States became something far more than workplaces. They became symbols of unity, innovation, sacrifice, and determination. They formed an industrial colossus that no enemy could match. A colossus born not from military tradition, but from the creativity and strength of ordinary citizens who reshaped their daily routines into a collective act of resistance. This was the moment America proved that industry could become a weapon every bit as powerful as a tank or bomber. The nation had awakened, and the arsenal of democracy was no longer an idea. It was a reality forged in steel, sweat, and unstoppable resolve. Across the nation, the momentum of industrial transformation accelerated into something immense and unprecedented. A coordinated, unstoppable surge of production that began to shape the very identity of the United States. Factory managers who once fought for market share now spoke in the language of tonnage, deadlines, and quotas. Every day brought new challenges, shortages of machine tools, transportation bottlenecks, or sudden revisions from the War Department demanding different calibers, new designs, or faster delivery. Yet instead of collapsing under pressure, American manufacturers adapted with stunning speed. Engineers redesigned equipment on the fly, machinists altered dies in hours instead of weeks, and supply chains once built for consumer goods reconfigured themselves to deliver war materials. The nation was learning to accelerate, to embrace improvisation, scale, and precision simultaneously, building an industrial rhythm that fed directly into the Allied war effort. One of the most transformative developments during this period was the rise of standardized manufacturing. Before the war, much of American production, especially in aviation, relied on skilled craftsmen who fitted parts by hand. But war demanded numbers, not artistry, and so factories began embracing mass standardization with almost religious devotion. Components were redesigned to use fewer materials, fewer steps, and fewer variations. Jigs and fixtures replaced artisanal craftsmanship, ensuring that parts from California could be snapped into assemblies built in Michigan or Ohio without adjustment. The effect was revolutionary. Errors plummeted. Output soared. Entire aircraft plants shifted from producing dozens of planes per month to hundreds. The process of standardization not only reshaped production but also created a new philosophy. Efficiency itself became a wartime weapon, capable of saving lives on the battlefield by accelerating the flow of equipment. Aviation, in particular, became the crown jewel of the wartime American miracle. In places like Seattle, Burbank, Buffalo, and Long Beach, hangars expanded into sprawling industrial cities of their own. Douglas Aircraft, Boeing, Lockheed, and North American Aviation employed tens of thousands of workers each. Engineers tinkering with aerodynamics, riveters sealing aluminum skins, women operating overhead cranes with the confidence of seasoned veterans. New airframes such as the P-51 Mustang, the B-17 Flying Fortress, and the C-47 Transport were not just technological marvels, they were triumphs of production. Lines of fuselage segments stretched across factory floors like metallic skeletons, while trucks and railcars shuttled parts between assembly wings. As workers tightened bolts and sealed joints, they understood that every aircraft was a promise to soldiers overseas, a promise of protection, mobility, and firepower. American skies above the assembly lines buzzed with test flights from dawn to dusk, reminders that the nation's growing arsenal was already leaping into action. Yet the miracle of aviation would not have been possible without the quiet revolution happening in machine tool plants, the often overlooked backbone of the entire war effort. Machine tools were the mother machines, the precision instruments that shaped every rivet, gear, and bearing used in weapons systems. In factories across Connecticut, Illinois, and Ohio, toolmakers worked with microscopic tolerances, crafting lathes, milling machines, grinding tools, and drill presses with meticulous care. These tools were then shipped by the thousands to other manufacturers, enabling them to build aircraft engines, tank suspensions, artillery shells, and naval turbines. The demand was so high that machine tool output nearly quadrupled within a few years, a feat that stunned economists and military planners alike. Without this surge, without the quiet mastery of toolmakers and machinists, America's ambitious production goals would have crumbled before they began. Meanwhile, the chemistry and rubber industries underwent their own sweeping transformations, driven by the alarming reality that the U.S. had lost access to most of the world's natural rubber supply when Japan captured Southeast Asia. In response, American scientists worked around the clock to develop synthetic rubber on a scale never attempted before. Laboratories partnered with chemical giants like DuPont, Firestone, and Standard Oil, creating new blends that could withstand heat, pressure, and constant wear. Entire factories sprang up dedicated solely to synthetic rubber, feeding the insatiable demand for tires, gaskets, boots, insulation, and fuel lines. In a matter of months, the impossible became routine. Trucks received synthetic tires, aircraft rolled on synthetic treads, and the U.S. military maintained mobility across continents because scientists and chemists had willed a replacement into existence. It was another example of American ingenuity turning crisis into innovation. Just as critical were the sprawling ordnance plants that produced the munitions required for global warfare. Ammunition factories became some of the most dangerous yet essential workplaces in the country. The air inside was heavy with the smell of cordite and chemical solvents, and workers, mostly women, handled explosive materials with solemn focus. These plants manufactured billions of rounds of ammunition in countless calibers, from rifle cartridges to massive naval shells. They assembled landmines, bazooka rounds, grenades, and artillery fuses with astonishing speed. Inside the facilities, brightly painted safety zones marked areas where sparks could be fatal, and workers donned conductive shoes, static-free smocks, and face shields. The pace was relentless, but the stakes were greater than any discomfort. Every crate leaving the plant meant frontline soldiers would not run out of firepower when it mattered most. Workers themselves became central figures in the narrative of American production. For many families, the factory paycheck was the first steady income they had seen since the Depression. But the job was more than employment, it was duty. Newspapers published stories of mothers working double shifts while their sons fought overseas, of teenagers lying about their age to join the assembly lines, and of retirees returning to work out of patriotism. Ethnic communities, Polish, Italian, Irish, Mexican-American, and African-American, came together in workplaces that had once been segregated by skill or prejudice. While discrimination persisted, the shared urgency of war chipped away at barriers and forced companies to rethink hiring practices. For millions, this was not just industrial labor, but a chance to be part of something larger than themselves, a shared national struggle that unified people across class and background. By mid-1942, the combined effect of all these transformations became visible not only in factories, but across the American landscape. Railroads groaned under the weight of shipments carrying tanks, aircraft wings, ammunition crates, and raw materials across the continent. Highways filled with convoys of military trucks. Ports stacked with cargo destined for North Africa, Britain, and later the Pacific Islands. America was not merely preparing for war. It was feeding the Allied war machine with such force that military analysts around the world began rewriting their expectations. Across the swelling industrial landscapes of America, one reality loomed above all others. Vast quantities of weapons could not reach the battlefield unless they were driven, lifted, hauled, or powered by engines capable of enduring the brutal demands of global war. As the United States intensified its output, engine factories became sanctuaries of relentless innovation and engineering precision. These were not quiet workshops, but roaring cathedrals of metal, heat, and momentum. Rows of crankshafts glistened under factory lights. Turbine blades were measured to fractions of a millimeter, and assembly lines thrummed as pistons, casings, and magnetos snapped into place with hypnotic regularity. Engineers knew that each completed engine represented not just horsepower, but survival, the difference between an Allied advance and a battlefield disaster. Factories such as Pratt & Whitney, Allison, and Wright Aeronautical became vital command centers of the industrial war, their products destined to propel fighters, bombers, tanks, and landing craft across every theater. Aircraft engines, in particular, demanded a degree of sophistication unrivaled by any other wartime machinery. The Pratt & Whitney R-2800 Double Wasp, an air-cooled radial engine of stunning complexity, became one of the most important power plants of the war, capable of pushing aircraft like the F-4U Corsair and P-47 Thunderbolt to speeds that stunned Axis pilots. Its creation required thousands of precision parts machined to almost surgical accuracy. Workers trained specifically to handle the Double Wasp moved along the lines like surgeons performing a ritual, tightening bolts to exact torque values, consulting micrometers, and inspecting valve assemblies with unwavering concentration. Each test firing sent vibrations through the building, the sound of controlled fury echoing as flames spat from exhaust stacks. These engines were the beating hearts of the Sky War, and their reliability became legendary. Without them, air superiority, a cornerstone of Allied victory, would have been unattainable. The tank engines rolling off production lines carried their own burdens. The M4 Sherman, America's most widely used tank, required an engine powerful enough to handle rough terrain while remaining easy to repair in the field. The Continental R975 radial engine, a converted aircraft design, proved remarkably effective. Built in converted automobile plants, these engines dropped into Sherman hulls with impressive speed, thanks to simplification and standardization that allowed mechanics to perform major repairs in under an hour. In the factories, the smell of oil and hot steel filled the air as teams worked in disciplined formation, lowering engine blocks with cranes and testing them under simulated battlefield strain. Every engine that passed through quality testing meant that a tank crew somewhere, perhaps in North Africa, later in Normandy, or deeper still into Europe, would have the power to advance, survive, and fight another day. The automotive industry's contribution to engine production reflected the immense adaptability of American manufacturers. Ford's giant River Rouge complex, a symbol of assembly line mastery, reoriented its capabilities from mass-producing cars to supplying engines for military trucks, utility vehicles, and mobile artillery platforms. General Motors plants did the same, turning their automotive engineering expertise into an advantage the military sorely needed. Military trucks powered by GMC or Studebaker engines became the backbone of Allied logistics, carrying food, ammunition, medical supplies, and fuel across deserts, mountains, and muddy European roads. Their reliability was so respected that Soviet soldiers joked that the Studebaker was the truck that won the war, a reminder that engines built in Detroit could alter the fate of battles fought thousands of miles away. Every convoy rolling across hostile terrain was a testament to American engineers who ensured that power met purpose. Naval propulsion created an entirely different challenge. Engines had to operate for months without failure while enduring corrosive seawater, violent weather, and enemy attack. Shipyards along the Atlantic and Pacific coasts built massive diesel and steam turbine engines for destroyers, cruisers, and supply vessels. In cavernous workshops, machinists installed gigantic propeller shafts, engineers calibrated turbine blades for maximum efficiency, and foundry workers poured molten metal into molds for engine housings. The roar of a newly installed marine diesel engine reverberated through ship hulls, its rhythmic pulse a promise of endurance. These engines would carry ammunition to the Pacific Islands, shepherd convoys across U-boat-infested waters, and deliver Marines to beaches where the future of the war would be decided. Without these power plants, no ship could cross the oceans. Without these ships, no global strategy could function. Perhaps the most secretive and technically demanding work of all took place in laboratories developing engines for long-range bombers. The Wright R-3350 duplex Cyclone, intended for the B-29 Superfortress, required a level of engineering that pushed the limits of American industrial science. Engineers confronted persistent issues, overheating cylinders, fuel efficiency problems, and the sheer magnitude of a 2,200 horsepower design that strained conventional manufacturing tolerance. Yet they persevered. Each improvement brought the B-29 closer to operational readiness, enabling an aircraft capable of flying higher, farther, and faster than any previous bomber. The ultimate results of this engine's power would shape the final months of the Pacific War, though in 1942-43, its success was still uncertain. The determination to perfect it reflected a national mindset. No engineering challenge, however immense, could be allowed to slow the momentum of the arsenal of democracy. The human force behind engine production was as vital as the engineering itself. The work was physically demanding and mentally exhausting. Factories operated in shifts that never ended, with morning crews passing tools to night crews in a continuous cycle of fabrication and refinement. Women who had never held a wrench learned to torque bolts to precise specifications. Men who had spent decades repairing farm equipment found themselves machining aircraft cylinder heads. Immigrant communities brought mechanical traditions from Poland, Italy, Germany, and Scandinavia, transforming skills passed down through generations into engines that powered modern war machines. African American workers, long excluded from skilled positions, entered industrial training programs and rose into roles as machinists, inspectors, and mechanics. The workforce became a living display of national unity, millions of individuals contributing to a single shared purpose. By the midpoint of the war, the scale of American engine production had reached staggering levels. Fighter aircraft powered by American engines patrolled the skies over Europe. Tank columns crossed battlefields with engines growling beneath armored hulls. Naval fleets steamed across oceans under the power of American-built turbines. And trucks, tens of thousands of them, rumbled across continents delivering the lifeblood of Allied logistics. The factories producing these engines had become the true engines of victory, their output shaping every battlefield, every campaign, every Allied success. Across America's industrial heartlands, a new kind of soldier emerged, one without a rifle, helmet, or battlefield. These were the workers who filled the factories at dawn, who tightened bolts with frozen fingers in winter, who wiped sweat from their eyes as furnaces glowed red in summer. As the arsenal of democracy expanded, the nation discovered that victory would be decided not only on foreign battlefields, but also along assembly lines stretching from Detroit to Pittsburgh, Seattle to Birmingham. Every shift change became a symbolic changing of the guard. Every punch of a time clock echoed like a drumbeat of mobilization. America's industrial workforce, once divided by class, race, and region, began to reorganize itself into a unified, disciplined force, an enormous human engine driving the machinery of war. For many workers, the transition into wartime production happened almost overnight. Men who had long labored in automobile plants found themselves crafting parts for Sherman tanks. Women who once tailored dresses stitched parachutes with the precision of military riggers. Coal miners dug deeper into the earth to keep steel mills blazing, while machinists learned the intricacies of aircraft components that demanded tolerances far tighter than any consumer product. Each new skill, each recalibration, chipped away at the idea that industrial work was somehow separate from the war effort. Instead, factories turned into the front lines of American power. Supervisors issued orders with the same urgency as officers in combat, and workers accepted the weight of responsibility, understanding that a single mistake could cost a pilot his life or a ship its chance of returning home. This transformation drew millions of women into roles once denied to them. The Rosie the Riveter archetype, though later mythologized, represented a real and profound shift in the American workforce. Women learned to weld frames for Liberty ships, operate hydraulic presses, and assemble delicate gyroscopes used in bombers. Their hands shaped the sinews of the war machine with unwavering precision. In some plants, women made up more than half the workforce, challenging pre-war assumptions about ability and redefining societal norms. Their presence infused factories with a sense of shared sacrifice that went beyond patriotism. It became a movement of empowerment, resilience, and national necessity. They showed that victory depended not on who wore the uniform, but on who was willing to give every ounce of effort to secure the future. Equally important were the contributions of African American workers, who faced prejudice even as the nation demanded their labor. Many were initially relegated to the least skilled or most hazardous jobs, but pressure from civil rights leaders and a growing labor shortage forced industry to open skilled roles. Once allowed into training programs, black machinists, welders, inspectors, and technicians excelled quickly. In bomber factories, African American women inspected aluminum skins for microscopic flaws. In shipyards, black welders fused steel plates that would face the brutal pressures of the North Atlantic. Their work not only strengthened the industrial output of the nation, but also challenged the racial barriers that had long undermined American unity. Every completed engine, every gasket, every riveted seam became both a contribution to victory and a quiet weapon in the struggle for equality. Immigrant communities brought their own strength to the industrial warfront. Polish machinists with generational mechanical knowledge, Italian metalworkers with the instincts of artisans, German engineers who had fled fascism, all brought expertise that enriched American production. In cities where dozens of languages were spoken across factory floors, the war effort became a tapestry of global skills united under a single purpose. Many of these immigrants had escaped the violence gripping Europe, and for them, building weapons for the Allies carried profound personal meaning. Their work bore the emotional weight of families left behind, of homelands overtaken, of a hope that the machines they helped construct might one day liberate their old lives from tyranny. The workplace itself evolved into a high-intensity environment shaped by the relentless demands of modern war. Factories instituted around-the-clock shifts that blurred the boundaries between day and night. Whistles signaled the start of news cycles with military precision. Cafeterias served meals by the thousands. Medical stations treated burns, cuts, and exhaustion. Noise became an omnipresent force, hammers ringing against metal, drills whining through steel, engines roaring through test chambers. Amid this chaos, workers developed a fierce camaraderie, bound together by the knowledge that their collective labor could tip the scales of global conflict. A machinist in Chicago understood that somewhere across the world, a pilot depended on the propeller shaft he had just finished polishing. A welder in San Francisco knew that her rivets held together the hull of a ship that might carry troops to victory. Even outside the factories, the rhythm of industrial mobilization infiltrated American life. Families reorganized routines around night shifts. Children learned to identify different factory whistles. Local newspapers printed production quotas as if they were battlefield reports. Communities adopted victory gardens, conserved fuel, and held scrap steel drives to feed the voracious appetite of wartime industry. Entire neighborhoods pulsed with the urgency of collective purpose. Churches prayed for factory workers as they prayed for soldiers. Schools taught mechanical skills. Civic groups volunteered at plant canteens. The separation between civilian and military life grew thinner with each passing month, creating a national atmosphere of determination, anxiety, and unwavering resolve. By 1943, America's workers had become the backbone of the arsenal of democracy, a silent army whose discipline, endurance, and adaptability rivaled that of any military force. They did not fight with rifles or artillery, yet every bomber sortie, every tank advance, every convoy crossing the Atlantic bore the imprint of their labor. Their contribution was not merely industrial, it was moral. In every rivet-driven seam and every polished piston, they inscribed a declaration of national unity and defiance. Their work proved that democracy, when fully mobilized, could summon a strength that dictatorships could neither predict nor match. And as the factories roared into their peak, America's workers stood unshakably at the center of the fight for freedom, an army of millions forging victory one shift at a time. As America's factories churned out planes, tanks, and ships at a pace unprecedented in human history, another monumental challenge emerged, moving this arsenal from assembly lines to the front lines of battle. The logistical task was staggering. Rail networks groaned under the weight of heavy machinery. Trucks rumbled day and night, carrying vital components, and ports swelled with Liberty ships ready to sail across storm-tossed oceans. Each shipment was a complex ballet of coordination, timing, and precision. Cranes lifted tanks onto rail cars with surgical exactness. Conveyor belts funneled crates of ammunition into waiting warehouses, and dockworkers navigated the chaos of shifting cargo, knowing that any delay could jeopardize a campaign thousands of miles away. It was not enough to build the arsenal. The nation had to deliver it, and quickly. The railroads became arteries of industrial life. Thousands of miles of track connected inland factories with coastal ports, ensuring that tanks, aircraft engines, and artillery could reach shipment points efficiently. Freight schedules were rewritten daily, prioritizing military cargo over commercial needs. Locomotives strained under the weight of heavily loaded cars, while crews worked around the clock, often sleeping in cramped cabooses between stops. Every delay, every broken rail or mechanical failure demanded improvisation. Maintenance crews raced along tracks, repairing engines and reinforcing bridges, aware that the flow of material was as vital to victory as the bullets themselves. In this sprawling network, engineers, conductors, and logistics specialists became silent generals, commanding movement with precision rivaling battlefield strategy. Ports on both coasts transformed into massive hubs of maritime activity. Cranes, gantries, and winches orchestrated a ceaseless dance of loading and unloading. Liberty ships were launched at record speed, their holds stuffed with everything from tanks to food rations to medical supplies. Dockworkers coordinated with shipping clerks, ensuring that each crate was accounted for and stowed in exact sequence to allow rapid unloading upon arrival. Safety was a constant concern. Improperly stacked cargo could capsize a vessel, while mishandled munitions posed catastrophic risk. Yet despite the constant danger, the efficiency of the ports grew with each passing month. Shipbuilding and shipping became an intertwined system, a testament to American organizational skill and industrial ingenuity. The trucking networks extending from factories to railheads and ports added another layer of complexity. Millions of tires, engines, and spare parts were required to keep thousands of vehicles operational. Mechanics and logistics officers coordinated convoys, calculated fuel needs, and planned routes to avoid bottlenecks. Rural highways, once quiet, now throbbed with military transport, while city streets became labyrinths of industrial output. Drivers faced grueling hours, navigating unfamiliar terrain, often in dangerous weather, knowing that the tanks, guns, and supplies they carried could determine the outcome of distant battles. Each mile traveled was a silent act of war, a vital thread in the lifeblood of Allied strategy. Even overseas, the supply lines were under constant threat. German U-boats prowled the Atlantic, targeting convoys with lethal precision. Every Liberty ship that slipped past the wolf packs represented a triumph of American planning, technology, and courage. Convoy systems were implemented, with escort vessels shielding merchant fleets while coordinated radio communications ensured navigation and protection. Engineers innovated with new hull designs and compartmentalization techniques to mitigate losses from torpedo strikes. Sailors and merchant mariners endured storm and enemy fire alike, relying on the reliability of engines. Engines built thousands of miles away by American hands to keep them moving. The war was being waged not only on the battlefield but along these tenuous veins of supply that connected production to combat. Industrial coordination extended beyond hardware to include the raw materials that fed the production engine. Mines, forests, and refineries across the United States supplied steel, aluminum, copper, rubber, and fuel at scales previously unimaginable. Resource managers allocated materials with near-military precision, ensuring that each factory had the necessary components to maintain production quotas. When shortages arose, engineers improvised alternative alloys, redesigned components to use less material, and pushed the boundaries of innovation. The integration of raw material management, production scheduling, and transportation planning formed a network that was itself a strategic weapon, capable of outproducing and outlasting any adversary. The human element behind these supply lines was as critical as the machines they supported. Dock workers, railroad crews, truck drivers, and supply officers endured fatigue, harsh conditions, and relentless schedules. Their labor was often invisible, overshadowed by the glamour of battlefield heroics. Yet without it, planes could not fly, tanks could not advance, and armies could not be fed. Communities across the nation understood this connection, and morale campaigns emphasized the importance of every effort, from a rivet in a tank to a shipment of canned food for soldiers abroad. Patriotism became measured not only in courage under fire, but in diligence on the home front. By late 1942, America's supply system had reached a scale and sophistication that stunned both allies and enemies. Military planners marveled at the speed with which material could be moved from factory floor to front lines. Allies across Europe and Asia began relying on American shipments as the foundation of their operations. And even as Axis powers schemed to disrupt these flows, the United States continually adapted, building faster ships, improving convoy tactics, and expanding domestic transportation infrastructure. The arsenal of democracy was no longer just a factory-driven promise. It was a living, breathing network of movement, endurance, and power, silently delivering victory across oceans and continents. Across the American coastline, a transformation of staggering magnitude unfolded. Shipyards that had once produced modest commercial vessels were now sprawling fortresses of steel and human ingenuity. The demand was immense. Liberty ships, destroyers, aircraft carriers, and landing craft had to be constructed with unprecedented speed, precision, and reliability. Every yard became a hive of activity, with cranes swinging massive steel plates, sparks flying from welding torches, and the roar of pneumatic riveters filling the air. Workers, many of them unskilled only months before, learned rapidly, mastering the delicate choreography of hull assembly, engine installation, and armament mounting. Each vessel launched represented more than metal. It was a tangible manifestation of America's commitment to sustaining the global fight for freedom. Liberty ships, the backbone of Allied logistics, epitomized the ingenuity and urgency of the era. Designed for rapid, cost-effective construction, these vessels could carry vast quantities of supplies, troops, and equipment across treacherous oceans. Shipbuilders developed assembly line techniques unprecedented in maritime history. Prefabricated sections were manufactured inland, transported to coastal yards, and welded together with astonishing efficiency. Entire ships were completed in weeks, a pace previously unimaginable. Every rivet, every seam, every engine test reflected the ingenuity of American engineers and the tireless labor of thousands. These vessels became the lifeblood of Allied operations, enabling forces to reach distant theaters and maintain momentum against Axis powers. Warships, by contrast, demanded meticulous craftsmanship and technological sophistication. Destroyers, cruisers, and aircraft carriers required precision engineering, integrating engines, weaponry, radar systems, and communication networks. Shipyard workers became artisans of steel and fire, balancing speed with perfection. Turrets were aligned to fractions of an inch, propulsion systems calibrated to withstand months of continuous operation, and radar and sonar systems meticulously tested. Each ship embodied the fusion of industrial might and military science, a floating fortress capable of asserting dominance on the high seas. Engineers, naval officers, and laborers collaborated tirelessly, aware that every vessel was a weapon in the broader strategy of global warfare. The scale of shipbuilding demanded coordination across multiple sectors. Steel mills worked in unison with machine shops, providing plates, beams, and rivets at precise dimensions. Engine manufacturers synchronized production schedules to deliver propulsion systems on time. Ammunition plants supplied naval guns, depth charges, and torpedoes to arm each vessel. Logistics officers choreographed the delivery of supplies, ensuring that ships could be launched and immediately equipped for combat. It was a symphony of production, an industrial orchestra in which every section had to perform flawlessly. Any misstep could delay deployment, compromise supply lines, or endanger lives on distant battlefronts. Women, who had already reshaped the workforce in aircraft and vehicle production, played an equally crucial role in shipyards. They operated welding torches, assembled gun mounts, and tested engines under conditions that demanded both skill and courage. Their presence challenged traditional gender roles and showcased the adaptability and determination of a nation at war. Men and women, often working side by side for the first time, learned to rely on one another, forming teams that could tackle the complex, physically demanding tasks of maritime construction. Communities near shipyards swelled with workers, transforming once quiet towns into bustling centers of national purpose. The introduction of new technologies accelerated production further. Welding replaced traditional riveting in many applications, allowing stronger, lighter, and faster construction. Prefabrication techniques reduced time in dry docks, enabling multiple ships to be built simultaneously. Innovations in engine design increased efficiency, reliability, and speed, while improvements in hull construction enhanced durability against enemy attacks. American engineers were constantly experimenting, refining designs based on both feedback from the field and advances in materials science. This relentless pursuit of innovation ensured that the United States not only met demand, but consistently surpassed expectations. Supply chains extended across the continent to feed the shipyards. Lumber, steel, copper, aluminum, and rubber flowed from mines, forests, and refineries into the hands of shipbuilders. Railroads, trucks, and waterways delivered these materials in a seamless chain, each link synchronized to prevent bottlenecks. In wartime cities, streets thrummed with the movement of raw materials and finished components, while workers coordinated schedules down to the hour. The flow of goods became a lifeline, every shipment carrying the weight of global strategy and the hope of Allied victory. By the end of 1942, America's maritime arsenal had reached a scale that redefined naval warfare. Hundreds of Liberty ships traversed the Atlantic, protecting supply lines to Europe and Africa. Destroyers patrolled contested waters. Aircraft carriers launched squadrons to secure the Pacific, and landing craft prepared for amphibious invasions that would turn the tide in multiple theaters. The synergy between shipbuilding, engineering, logistics, and human effort had created an industrial juggernaut capable of projecting power across oceans. In every steel hull and every whirring engine, the arsenal of democracy had found its most visible, most enduring symbol. America could build not only weapons but the very means to deliver them where they were needed most, ensuring that freedom could fight and win on a global scale. In the vast hangars of American aviation factories, the roar of engines and the smell of burning oil became as familiar as the dawn. Here, amidst scaffolding and gantries, thousands of workers shaped the aircraft that would dominate the skies of Europe, the Pacific, and beyond. Airplanes were not mere machines. They were embodiments of industrial ingenuity, symbols of a nation determined to protect democracy with speed, altitude, and firepower. From the assembly lines of Boeing, Lockheed, and North American Aviation to smaller subcontractors scattered across the country, a new kind of aerial army took form, each plane meticulously crafted to meet the demands of a global war. Fighter aircraft like the P-51 Mustang and the F-4U Corsair demanded precision and innovation. Engineers labored over aerodynamic designs, ensuring that every wing, fuselage, and control surface could withstand high-speed maneuvers and heavy gunfire. Mechanics and assemblers worked with extraordinary care, aligning engines, calibrating instruments, and testing hydraulic systems. Each engine test filled hangars with a thunderous pulse, a heartbeat echoing the promise of air superiority. The pilots who would someday climb into these cockpits depended entirely on the unseen dedication of thousands of hands that had shaped, inspected, and perfected their machines. Bombers, larger and more complex, were feats of coordination and endurance. The B-17 Flying Fortress and the B-24 Liberator required engines, electrical systems, and armaments that rivaled the complexity of small cities. Assembly lines stretched for miles, with teams specializing in wings, fuselage, landing gear, and defensive gun positions. Workers calibrated bomb release mechanisms, tested oxygen systems, and meticulously ensured structural integrity. Flight tests became critical rituals. A plane had to meet strict performance standards before it could leave the factory. Each successful aircraft represented not only a potential tactical advantage, but the culmination of precise engineering, relentless labor, and unwavering national will. The scale of production was staggering. Factories operated around the clock, with shift changes synchronized to maintain continuity. Women, who had become indispensable in other industrial sectors, now dominated aviation production floors, riveting fuselages, installing wiring, and learning the intricacies of flight-critical systems. African American workers, often trained under new wartime programs, contributed as inspectors, mechanics, and machinists. Immigrant expertise, long nurtured in small machine shops and artisan workshops, now amplified the nation's capability. Each aircraft that rolled off the line was the result of a vast, interconnected web of talent, dedication, and coordination, reflecting the human engine behind the machines of war. Raw materials fed this aerial assembly like blood to a living organism. Aluminum from mines in the Rockies and the South, steel from Pennsylvania mills, copper from Western mines, and rubber from Caribbean imports flowed into factories with exacting precision. Logistics teams ensured that shortages never halted production. When bottlenecks threatened schedules, engineers adapted designs, sought substitutes, or reconfigured assembly processes. The integration of production, material supply, and quality control created an industrial ecosystem capable of outproducing and outlasting Axis rivals. It was a war of materials as much as a war of men and machines, and America's supply chain became a strategic advantage on an unprecedented scale. Testing and training were inseparable from production. Newly built aircraft were taken to specialized airfields where test pilots pushed them to their limits, stalling, diving, climbing, and firing simulated ordnance. Engineers observed each flight, recording vibrations, engine performance, and control response, adjusting designs accordingly. Meanwhile, mechanics were trained to maintain aircraft under harsh combat conditions, ensuring that planes could survive extended missions over hostile territory. This relentless cycle of production, testing, and refinement guaranteed that when American pilots entered combat, their machines would perform with precision, reliability, and lethality. The impact of these aircraft extended far beyond the factory floor. Fighters escorted bombers deep into enemy territory, protecting supply lines and striking industrial centers. Bombers destroyed factories, transportation hubs, and strategic infrastructure, weakening the Axis war machine. Observation planes gathered intelligence, mapping enemy positions and movements. Each sortie relied on countless workers who had never seen combat, yet had dedicated their lives to building the tools that enabled freedom to soar. The air war became a testament to the interdependence of industrial capacity, human labor, and strategic vision. By 1943, America's air power had achieved a scale and sophistication that reshaped global conflict. Pilots flew aircraft built in hundreds of factories across the nation, engines calibrated to perfection, airframes rigorously tested, and weapon systems fully operational. Every completed plane represented the culmination of human ingenuity, industrial might, and national resolve. The arsenal of democracy had become not just a supplier of weapons, but a creator of dominance in the skies, delivering freedom with every propeller turn and every roar of jet-age engines. America's industrial wings carried the hopes of a world at war, ensuring that the fight for democracy would reach every corner of the globe. Beyond the steel and wings of airplanes, another transformation surged through America's factories: the mass production of armored vehicles, trucks, and artillery that would carry the fight to every theater of war. Factories once dedicated to consumer automobiles, tractors, and industrial machinery were swiftly repurposed into vast plants of armored engineering. Assembly lines stretched for miles, where tanks like the M4 Sherman took shape under the hands of mechanics, engineers, and laborers who understood that each vehicle would carry soldiers into the most perilous zones of combat. The roar of engines, the clang of metal, and the hiss of steam presses became the soundtrack of a nation turning industry into instruments of survival and dominance. Tanks, with their heavy armor and complex weapon systems, demanded a marriage of precision engineering and brute force. Tracks were painstakingly assembled, gun turrets calibrated to exact tolerances, and engines tuned to endure the harshest battle conditions. Workers welded and machined with absolute focus, aware that even a single flaw could mean the difference between life and death for the crews inside. Munitions were prepared alongside vehicles, integrated with tanks and self-propelled guns, ensuring that the machines rolled off the assembly line combat-ready. Every Sherman, every M3 Lee, every variant represented not merely industrial capability, but tactical ingenuity, a direct response to the challenges posed by mechanized warfare. The production of trucks and support vehicles was equally critical. Millions of cargo trucks, half-tracks, and utility vehicles formed the backbone of logistical operations, transporting troops, ammunition, food, and medical supplies across continents. Plants that had produced family cars now churned out vehicles capable of enduring deserts, jungles, and frozen plains. Engineers adapted designs for heavy loads, rugged terrain, and battlefield conditions. Drivers and mechanics were trained simultaneously, ensuring that these vehicles could sustain operations far from supply depots. The mobility they offered allowed armies to respond flexibly, strike rapidly, and maintain momentum, a critical advantage in a war defined by speed and coordination. Artillery production transformed factory floors into crucibles of firepower. Howitzers, anti-tank guns, and mortars were meticulously manufactured, tested, and calibrated. Teams of machinists and metalworkers worked together to achieve accuracy and reliability, while transport wagons, gun carriages, and support mechanisms were fabricated in parallel. Every cannon bore the precision of skilled hands, and every shell produced in ordnance plants represented a promise of long-range impact. The integration of artillery with armored units and infantry formations was studied and refined even during production, ensuring that each piece of equipment could be deployed effectively in the complex choreography of modern combat. Women again played a transformative role. In many factories, they riveted armor plates, inspected engine assemblies, and assembled electrical components for tanks and trucks. Their meticulous work ensured that vehicles met stringent standards for durability and functionality. African American workers, previously restricted to certain tasks, now filled critical roles in machining, assembly, and testing. Immigrants with experience in metalworking and mechanics contributed skills honed over decades, enriching the American war effort with expertise born of necessity. Factories became melting pots of talent, experience, and determination, united by a singular goal: to ensure that America's soldiers could face the enemy fully equipped. Innovation accompanied mass production at every turn. Engineers experimented with interchangeable parts, streamlined assembly methods, and modular design, dramatically reducing build times without compromising quality. Artillery was paired with trucks for rapid deployment, tanks were adapted for amphibious operations, and anti-aircraft guns were designed for quick relocation. Continuous feedback from military advisors in training camps and early combat zones refined designs, creating vehicles optimized for survival, mobility, and lethality. This fusion of industrial ingenuity and operational insight turned factories into laboratories of modern warfare, where theory and practice merged seamlessly. The integration of tanks, trucks, and artillery with broader military strategy transformed the very nature of combat. Armored divisions moved swiftly across Europe and North Africa, supported by endless convoys of trucks carrying fuel and supplies. Artillery barges softened enemy defenses, enabling infantry and mechanized units to advance. Mobility and firepower became inseparable, and every vehicle manufactured in America contributed to a chain of operations that spanned oceans and continents. Victory was no longer a distant objective. It was engineered, produced, and delivered through the meticulous labor of American industry. By 1943, the United States had achieved a level of combined arms production that stunned both allies and adversaries. Tanks, trucks, and artillery flowed in quantities sufficient to equip multiple armies simultaneously, each machine tested, refined, and integrated into a larger strategy of overwhelming force. The arsenal of democracy had proven that industrial power could translate directly into battlefield dominance, ensuring that America could project strength anywhere it was needed. Factories had become theaters of war, laborers the unsung soldiers, and steel and rubber the tangible embodiment of national resolve. Through these machines, America prepared not merely to fight, but to win. By 1943, the scale of American industrial output had transcended national borders, forming a vast global network of production, supply, and deployment that became the backbone of Allied operations. Factories in the Midwest churned out tanks and trucks, coastal shipyards launched fleets into Atlantic convoys, and aviation plants sent squadrons of planes into the skies. Every piece of machinery, every crate of ammunition, and every ton of fuel became part of a meticulously coordinated system designed to sustain global warfare. The challenge was immense: to ensure that material flowed seamlessly across oceans, deserts, mountains, and jungles, arriving where it was needed before battles were won or lost. The United States developed a sophisticated system of logistics planning that rivaled even the complexity of military strategy. Ports, railroads, highways, and airfields were synchronized to minimize bottlenecks. Convoys were scheduled with military precision, guarded against U-boat attacks and air raids, while warehouses and supply depots acted as distribution hubs for multiple theaters of operations. Engineers and logistics officers constantly adjusted routes, balanced production schedules, and coordinated with allies to ensure that no resource was wasted. In effect, the arsenal of democracy had become a living organism, with supply lines acting as arteries delivering lifeblood to every front. Lend-Lease agreements extended this industrial reach even further. American factories produced equipment not only for U.S. forces but also for Britain, the Soviet Union, China, and other allied nations. Tanks, planes, trucks, and ammunition crossed the Atlantic and Pacific Oceans in vast convoys, sustaining armies that otherwise would have struggled to equip themselves. This transfer of material required coordination on an unprecedented scale. Production schedules in Detroit had to match shipping capacities in New York, which had to align with unloading capabilities in Liverpool or Murmansk. The complexity was daunting, yet the system worked, turning American industry into a global force multiplier. Shipping, already a logistical marvel, became a central focus of strategic planning. Liberty ships and fast cargo vessels traversed hostile waters, escorted by destroyers and supported by intelligence networks that tracked enemy submarines. Convoy routes were continuously revised to minimize risk, while innovations in radar, sonar, and navigation improved safety and efficiency. Each successful crossing represented a triumph of coordination, engineering, and courage. Sailors, dockworkers, and logistics officers were engaged in a silent but critical war, ensuring that the equipment produced in American factories reached soldiers fighting on distant continents. Industrial intelligence played a key role in this coordination. Planners tracked production rates, monitored inventory levels, and predicted future needs with astonishing accuracy. When shortages threatened, alternative supply lines were established. When production outpaced demand, resources were reallocated to priority theaters. This level of planning allowed the Allies to respond with flexibility and speed, adapting to battlefield developments in real time. Factories became more than production sites. They were nerve centers of strategic foresight, shaping the very course of global conflict. The human workforce remained at the heart of this global system. Millions of Americans, men and women, young and old, skilled and unskilled, contributed to a massive effort that blurred the lines between civilian and military life. Labor unions, government agencies, and private companies collaborated to maintain efficiency, morale, and safety. Communities across the country were mobilized, with citizens volunteering for auxiliary roles, conserving resources, and supporting industrial output through sheer collective determination. Every rivet, every bolt, and every crate became a statement of national purpose. Technology and innovation drove the system forward. Engineers developed standardized parts that could be used interchangeably across different models of tanks and aircraft, simplifying repairs and maintenance. Assembly line techniques borrowed from automobile production were refined and adapted for military hardware. Communication networks spanning factories, ports, and military headquarters allowed rapid response to changing needs. The result was an integrated production grid that could sustain simultaneous operations on multiple continents, giving the Allies a decisive advantage. By the end of 1943, the United States had achieved a scale of industrial mobilization that reshaped the very nature of global warfare. Factories, ports, railroads, and airfields operated as an interconnected whole, delivering men, machines, and material to every front. Allied forces could advance with confidence, knowing that the arsenal of democracy was not a theoretical concept, but a tangible, unstoppable engine of victory. This intricate global network, fueled by American ingenuity, labor, and determination, had become the invisible force that underpinned every campaign, every battle, and every victory, ensuring that democracy could fight, endure, and ultimately prevail. Behind the immense machines, the ships, the tanks, and the planes, the arsenal of democracy depended on the tireless work of millions of Americans whose labor, ingenuity, and resolve turned raw materials into instruments of victory. In factories across the nation, workers labored long hours under intense conditions, their hands shaping steel, riveting armor, assembling engines, and installing weaponry. The deafening roar of machinery, the sparks flying from welding torches, and the constant rhythm of conveyor belts became the heartbeat of a nation fully mobilized for war. Each rivet, each bolt, each engine test carried a weight far beyond its mechanical function. It was a tangible act of commitment to global freedom. Women, previously excluded from heavy industry, became indispensable. They welded hulls, installed aircraft wiring, calibrated instruments, and managed production lines with precision and skill. The image of Rosie the Riveter became an enduring symbol of courage, adaptability, and determination, representing a workforce whose contribution rivaled any soldier on the battlefield. African American workers, long marginalized, stepped into critical roles in machine shops, assembly lines, and testing facilities, their expertise and perseverance adding indispensable layers to the war effort. Immigrant workers brought knowledge honed in workshops around the world, further enriching the industrial workforce. The collaboration of diverse communities demonstrated a national unity that paralleled the unity of the Allied cause. Innovation was as critical as labor. Engineers, designers, and technicians worked relentlessly to improve production processes, streamline assembly lines, and solve complex problems in real time. Prefabrication, modular design, and standardized components accelerated production and ensured reliability across weapons and vehicles. Factory managers implemented rigorous quality control, while military liaisons provided feedback from combat theaters, ensuring that equipment met operational demands. Laboratories, machine shops, and testing fields became crucibles of invention, producing machinery and munitions faster, lighter, stronger, and more effective than the enemy could imagine. Each advancement in design and efficiency translated directly into battlefield superiority. The emotional and psychological weight of this effort was immense. Workers understood the stakes. Every airplane delayed, every tank defect, every shipment misrouted could cost lives on distant battlefields. Yet amid exhaustion, injury, and relentless pressure, a sense of purpose fueled determination. Morale programs, patriotic campaigns, and shared awareness of global stakes instilled focus and pride. Communities contributed by rationing resources, conserving fuel, and volunteering in auxiliary roles. Schools, churches, and local organizations became support hubs, knitting together the civilian effort with industrial output. The war was waged not only in factories, but in every home, every town, every city that contributed to the machinery of victory. The coordination between industry and military strategy became a hallmark of American ingenuity. Production planners, engineers, and military officers collaborated closely to forecast battlefield needs, prioritize production lines, and allocate materials efficiently. Factories became centers of strategic calculation, where raw steel could be transformed into a tank one day and a bomber the next. Intelligence reports, field feedback, and production metrics informed decisions, creating a dynamic system that could adjust rapidly to changing war conditions. This fusion of human labor, technology, and foresight allowed America to act as the world's primary engine of sustained warfare. Heroes emerged not only on the battlefield, but also on the factory floor. Shipyard workers braved grueling schedules to launch Liberty ships on time. Machinists painstakingly crafted engines that would soar thousands of feet above enemy territory. Assemblers built tanks that would carry soldiers across hostile terrain. Their sacrifices were largely invisible to the public, yet their impact was monumental. Newspapers, radio broadcasts, and morale campaigns highlighted individual stories, reinforcing the understanding that industrial labor was a form of combat, a contribution every bit as vital as courage in battle. By 1944, the arsenal of democracy had reached its apex. Factories, ports, railroads, and airfields operated in seamless synchronization, producing unprecedented volumes of weaponry, vehicles, and supplies. Labor, innovation, and strategy converged to form a system capable of sustaining multiple global campaigns simultaneously. The human engine driving this industrial might was a testament to the resilience, adaptability, and determination of the American people. Each aircraft that lifted into the sky, every ship that set sail, and every tank that rolled across a foreign battlefield embodied the collective effort of millions, proving that the strength of a nation could extend far beyond its soldiers in uniform. America's industrial mobilization became a model of modern warfare, demonstrating that victory could be engineered, coordinated, and delivered with precision. Factories were not just sites of production, they were theaters of democracy, where ordinary citizens contributed to extraordinary outcomes. The arsenal of democracy was more than steel, rubber, and fuel. It was the embodiment of human resolve, innovation, and collective courage, proving that a nation fully committed to a cause could shape the destiny of the world. By the summer of 1945, the fruits of America's industrial mobilization were unmistakable. Across oceans, continents, and battlefields, the equipment, vehicles, and machinery produced by American factories had enabled Allied forces to achieve decisive victories. Tanks advanced across Europe, planes dominated the skies from Normandy to Tokyo, and ships sustained convoys that carried troops and supplies to the farthest reaches of conflict. The sheer scale of production had not only met the demands of war but exceeded them, creating a capacity so vast that it became a strategic advantage unmatched by any adversary. The United States had become the indispensable engine of global freedom, turning industrial might into tactical and moral victory. The human story behind this achievement was equally profound. Millions of Americans, men, women, immigrants, and African Americans, had contributed their labor, skill, and ingenuity, transforming raw materials into instruments of war. Factories had become theaters of courage and innovation, where every rivet, engine, and fuselage symbolized a commitment to a cause far larger than the individual. These workers endured long hours, dangerous conditions, and immense pressure, yet their resolve never wavered. Their contribution redefined the concept of national service, proving that victory could be built as much with hands and minds at assembly lines as with soldiers on the battlefield. The integration of technology, logistics, and strategy had achieved something unprecedented. Aircraft, ships, tanks, trucks, artillery, and munitions flowed seamlessly into combat zones, coordinated with intelligence, military planning, and diplomatic strategy. Every theater of war benefited from this precision, allowing Allied commanders to plan offensives with confidence, knowing that production and supply could sustain prolonged campaigns. This interconnected system transformed the nature of warfare itself, demonstrating that industrial capacity was not just a background factor, but a decisive instrument of strategy. Innovation remained central throughout the conflict. American engineers continually refined designs, developed new manufacturing processes, and adapted vehicles and weaponry to meet evolving battlefield conditions. Prefabrication, modular design, and standardization accelerated production and simplified maintenance in theaters far from home. The synergy between engineers, laborers, and military planners created an agile industrial force, capable of responding dynamically to strategic needs. It was not merely quantity that mattered, but quality, precision, and adaptability, the hallmark of the arsenal of democracy. The moral significance of this effort was inseparable from its practical impact. The United States had shown that a nation committed to the defense of freedom could marshal its people, resources, and ingenuity to meet a global threat. Factories became symbols of hope and determination, demonstrating that industrial power could translate into strategic influence, operational success, and ultimately, the liberation of oppressed peoples. The war's outcome owed as much to these factories and their workers as to soldiers and generals, highlighting a new paradigm in which civilian industry became a decisive factor in shaping history. Beyond the immediate victories, the arsenal of democracy left a lasting legacy. America emerged from the war not only victorious but transformed, with a manufacturing base, workforce, and technological infrastructure of unparalleled sophistication. Lessons learned in logistics, mass production, and coordination became models for future industries and military planning. The nation's capacity to mobilize, innovate, and integrate resources on a global scale would influence decades of policy, defense strategy, and economic development, underscoring the enduring power of organized, purpose-driven industrial might. The story of America's factories also reshaped cultural and social landscapes. Women's contributions in industry catalyzed changes in gender roles, African Americans gained new employment opportunities, and immigrant labor proved indispensable to national objectives. Communities rallied around the war effort, fostering a collective sense of purpose and unity. In every city with a shipyard, aircraft plant, or tank assembly line, ordinary citizens experienced the extraordinary responsibility of contributing to global survival, proving that democracy's strength rested not only in ideals, but in action. Ultimately, the arsenal of democracy demonstrated that a nation's industrial heart could become the backbone of its military power and moral influence. America's factories had done more than produce machinery. They had forged the means to project freedom across oceans, sustain global alliances, and turn strategy into victory. The triumphs of 1945 were not the result of chance, but the outcome of meticulous planning, relentless labor, and unwavering resolve. In steel, rubber, and aluminum, in the roar of engines and the hum of assembly lines, the story of America's commitment to democracy was written, an enduring testament to the extraordinary power of human ingenuity mobilized for a righteous cause.